Hello everyone. Last class when I took basics of geometry, idea was to take concepts which is very important for geometry. We have always learned geometry as a two theoretical subjects, but today's part of this lecture will tell you it is more logical than any chapter which we learn in aptitude. So be it number system, be it any of the mathematics part of aptitude, I believe geometry is much more logical today. I wrote triangle, and triangle is made of with three lines. We say three non-parallel space, make a triangle, and so its nomenclature is made like this. I say A, B, C, and then probably we have a interior angle concept, and then we have exterior angle concept that has been discussed in the previous video. Today I'll talk about what is new in triangle. If you look at number of parameters this triangle is having, one, it has an angle, another, it has a length because we represent its side in the form of small a, small b, and small c. Another perspective which is first time arrived to geometry when it comes to when area concept was introduced for the first time, because three side triangle is the first closed diagram. When you can't make a closed diagram with the two lines, obviously it will be oval, then probably the number of sides will not be two, but yes, three non-parallel lines will make a triangle, and then you get a closed loop, and closed loop means closed diagram, and that's where we get a concept called area. And area starts from the triangle, and then obviously we go for finding out the area of a quadrilateral, then area of the pentagon and the hexagon, and probably I can go up to a circle. Circle is nothing but n-sided polygon, and n is infinity. So infinite side equal, infinite side and all equal. So it is all called a circle of it. But obviously we are concentrating a three-side diagram, that's called triangle. Most basic formula which is known to us is called half base into height. But when we say base and when we say height, it is not like the bottom side is going to be a base of it. It's all depend upon which way I'm look at it. So triangle has a three sides, so it will have a three bases also. So I can take A as a base, I can take B as a base, I can take C as a base. It is of my choice. It is also depending on what questions we are solving and what data has been given to that. So if I try to make a height, what is height? So height in triangle is altitude which has drawn from the vertices. So whenever I select a side, so for example, I have selected BC. If I have selected BC, the A is going to be another vertex where B and C is not there. So I drop a perpendicular from A on BC, and this is what called H1. If I know the H1 value, I can say area of triangle is going to be half of A is the base and height is going to be H1. If I try to take a base of say any other side, I can drop, this is nothing but H2, this is on a base called AC. This can also be written as half B side, B multiple H2. Then what is left for selecting the base? That's nothing but AB. And AB, again I can drop a perpendicular this, and I get the value another, this is all the 90°. This is another height of it. So triangle has 3 sides. Each side can take position as a base, and the moment a side become base, I need to drop a perpendicular from the altitude. So it is nothing but half of C side of H3. So area of triangle is half base into height, but the moment my heights are different, the base pairs are different, I can represent this as a half base into height. What it mean if I just try to understand what is the importance of these heights? I can learn through the example. If I draw a triangle like this, and this is ABC, and this is a base of A, and I do not have information about other sides, so BC has been given, and I really want to find out what is the altitude, what is the height for this base. It is very clear, I cannot draw perpendicular from A to BC. I may draw a diagram like this, may put like this, but 90 must be 90, it cannot be 60 and you are drawing a 90-degree angle on it. It is important, whenever we have a question, you should draw a diagram which is as closer or approximated the angle provided in the question. So this is not the 90-degree, although I just try to forcefully drop a perpendicular and making a perpendicular sign on it, but it will not make a height on it. So essentially this is not the perpendicular. For the perpendicular, now I need to extend the base. So triangle says if your altitude is not coming on the base, it must come on extended side of the base. And once we extend, I can drop a perpendicular from A on BC. Look at the BC is a straight line, I can extend it. If this is H, now I can say the area of a triangle is half A into H. What will happen if this length is X? Will it make any difference on finding out the area of a triangle? My answer is no. Where that base comes on the, where that altitude comes on the base or extended side of the base will not make difference. It is just like if you know the base value, if you know the altitude or a height values, you can just multiply half base into height and you get the answer of it. If you just experiment with this, if I draw a parallel line to this, which is passing through, or say altitude. So I have a base BC. Now I am saying I am drawing a parallel line to BC which is passing through the top vertices. Now if I start drawing and start using this base value to create another triangle of it. So I have created another some 3-4 triangles here, and the area of all triangles is going to be same. And why it is going to be same? Because distance between the parallel line remains be H and base is A. So area of a triangle drawn in this figure is going to be half A into H. So I have to be very, very clear about it, what side I am selecting as a base, and then where I am dropping perpendicular on that base from the vertex, and that is what called the area of a triangle. If I just try to add some trigonometry in it, because a basic trigonometry, because trigonometry is nothing but handling angles and the relation of angles in a triangle where the trigonometry arrives. The most favorite part of a trigonometry where the geometrical shape comes as a right angle triangle. If I name it this right angle triangle ABC, so why it is called right angle triangle? If you just try to search, try to work it out why it is called right angle triangle, what is right in it? For the matter, what is this right hand? Why not this side of a hand is said to be a right hand? So what is right in the world? Very simple answer, where most of the people say so. Anybody in the world is right if the most of the people support his or her views. Else, there is nothing called absolute right and absolute wrong. But what is right in this? It is just to do with the gravity. So if you just take a weight of, you might have seen some Raj Mistri and somebody is working the construction side. They have a iron weight at the bottom. So it's a kind of a toy hanging, and the moment they hang it, it is always 90 degree to the surface of the ground. So angle which is made against the gravity, alongside the gravity, is called a right angle. So 90 degree is specially called a right angle triangle. But idea is not too much a discussion on right angle triangle. I just try to build what is the trigonometry part of it. So normally we see a relation between the side and side, or we see a relation between the angle and angle, because summation of interior angle is 180 degree, exterior angle sum of triangle is 360 degree, sum of two side is greater than the third side of it. So these kind of relation is very much segregated. Either it is a angle concept or it is a side concept. But trigonometry brings, Pythagoras basically brings these relation something unique. If I say sine theta, it says if it is perpendicular, this is base and this is height. Pythagoras says it is P by H. Is it some mathematics? Answer is no. Pythagoras wanted to connect side with theta. So he come up with some kind of hypothesis and then try to incorporate into a right angle triangle, which was the simplest of it. Then it says, okay, can you extend to cos theta? Can you go up to tan theta, which is P by B? We use it as it is. My one advice to all of you, if you're learning geometry, you learn this much part of trigonometry. It may not be very easy for you because you might not have learned trigonometry in your school days or in 11th and 12th, but it is as simple as that. Don't worry about it. Think in a perspective. Pythagoras talks about relation between the theta and the sides, and it gave three parameters, three different nomenclature: sine theta, cos theta and tan theta. And then they define also what it mean by sine theta, what it mean by cos theta, what it mean by tan theta. And you have to just memorize some angle and its values: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, and just write down the sine, cos and tan, and try to remember their values. Sine 0 is 0, sine 30 is 1 by 2, sine 45 degrees 1 by 2, sine 60 is root 3 by 2, and sine 90 is going to be 1. Is it something which is generated somewhere? Answer is no. Somebody experimented practically. They figured it out. The moment they make 90-degree, P by H gives value 1 by root 2. This is what the value you can do. You can experiment at home. You can just take a chair, have a height, try to slide some wooden stick, or you take a scale and try to make 30-degree with the compass and check, are you getting P by H 1 by 2 or not? So this is just I experimented value. Somebody is correlated to it. Cos happens like this. Cos 0 is 1. 30 is root 3 by 2. This is 1 by root 2. This is 1 by 2. This is going to be 0. So we say, okay, the way you carried sine, you do reverse of it. So look at it, 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Now you do differently. This is the 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. Tan is nothing but sine divided by the cos. Sine theta by cos theta is called tan theta. I can put the values accordingly by dividing. This will become 0. This will become 1 by root 3. This will become 1. This will become root 3. And this is called not defined. Why not defined? Because 1 by 0 will give infinite, and even whenever we divide any number by 0, that is called not defined. We don't know what is the value it. Somebody says, sir, it is infinity. But what is that infinity? What I am thinking infinity, what you think infinity, both infinity could be different. And so, infinity minus infinity is not 0. It can be any value. It can be infinity also. So infinity itself is said to be a not defined. So better, instead of writing infinity, you just use not defined, because aptitude never talks about something called infinity, which is very difficult to judge. So if you know that much basics, it is important, because if you don't know this, you'll not able to do some faster calculation in geometry, because geometry also brings a lot of theta. So 30 degrees, 60 degree, 45 degree, 90 degree, these are very basic common structure. And some values of sine, cos, tan can make you faster in calculation, because absence of knowledge of these numbers or these formulas will make your questions difficult, looks difficult for you. So come to this. If I take, for example, this is the angle C, and I want to write what is the value of sine C. So sine C, sine is always valid in a right angle triangle. So for me, if it is D, so ADC become a right angle triangle, because I drop a perpendicular from the A. And if I want to write down the sine C value, I can write it is H1 divided by a value B, because that is the hypotenuse. We say the sine C is perpendicular divided by hypotenuse. So if I write this, I'll be writing H1 by B. What is the value of H1 in this case? B goes on the other side of it. I can write it is B sine C. And I can actually make this as a value for H1. So what will happen if I go for H2? What value I get when I want H3? I think I can have a symmetry or a cyclicity in it. If it is B, then it is the B sine C. Then accordingly, what will happen to H2? It become a C sine A. For H3, it become a B sine A, and so the values can come. So if I want to replace H1 in this, it will come like this: half A, B and sine C. See how cyclic it is. The area of a triangle is half AB sine C. So if I go next, it will go half BC sine A. And if I write this, half CA or sine B. I can say the area of triangle is 1 half base into height, or I can say it is half of multiple of AD two sides into sine of angle in between it. So I need to find the area of a triangle. Not necessarily all the time I am going to get base and height in that diagram. I might get two of the sides and the angle between it. Look at the structure here. That structure will tell you if this is my first side, this is the second side, see the angle between it. If I have taken A and B, C is in between it. Similarly, if it is BC, so this is B, this is C, in between angle is going to be A. So idea is, if I can learn a new formula for area of a triangle, that is saying a half of multiple of any of two sides and sine of angle in between it. So I need to find out the angle in between it. I'm just taking another example of equilateral triangle. So I have drawn equilateral triangle. What happened? This is nothing but the 60-degree and all sides are A. So if I want to find out what is the area of equilateral triangle, so what I need to do, area is half of A into sine 60 degree. And the value of sine 60 degree to be known to me because I just made a table for you, and that can be easily written half of A times of root 3 by 2. If you solve it, it is root 3 by 4 A square. So we used to memorize it, the area formula for equilateral triangle. My simple take is, if it is given the angle between two sides are 60 degree and sides are equal, it is going to be half of A into A of sine 60 degree. Any random diagram, for example, somebody has drawn, this is the 3 length, this is the 5 length, this is 30 degree. What, or for the matter 60 degree, what is the area of this triangle? While writing it, I can write half of 3 into 5 of sine 60 degree, and I can find out the area of this triangle. So you need to remember, area of a triangle is half base into height or half of multiple of any of two sides and angle in between it. It will enable you to track any of a triangle and its area concept, because the questions given may not be all the time is right angle triangle. It will have some combination of it. It could be a scalar, it could be a right angle, it could be isosceles. So it is important us to know this. If I just extend what all other things comes into the area, and we will learn in the coming lectures how those area formulae arrived logically. So first we said the area of a triangle is half base into height and while drawing a diagram ABC, we also learn it is nothing but half AB sine C, BC sine A, and CA sine B. So this is one is multiple of any of two sides and sine of angle between it. There are some more. One is small r into S. This is also an area formula for a triangle. And I believe we must have known this as a formula. This is called Heron's formula. This is also another form of area concept where S is semi-perimeter. This S and this S is same. So I need to remember and learn logically of each and every area concept. Obviously, we'll have a detailed explanation for this, but right now I'm just trying to give you what all the areas formula exist into a triangle. So this is small r into S, again ABC upon 4R, or RA into S minus A, RB into S minus B, RC into S minus C. This is also an area formula. What it means when we say RA, RB, RC, I will explain it, but this is also a part of the area formula. Another area formula for triangle is 4 by 3 of under root S1, S1 minus A1, S1 minus B1, S1 minus C1. So I need to describe couple of newer variables which was not there earlier, because while doing this triangle as explanation, we have just learned this is the triangle and which has a side ABC. So we are very much comfortable when we are using AB, sin C, angles are there. But what about S, which is defined, because S is nothing but a semi-parameter, but still we have a parameter like small r, capital R, RA, S1, A1, B1 and C1. These all the variables are not defined by me yet. And I think if I just define, obviously logical explanation will touch in the next one, where when we'll be discussing different centers of the triangle, because the moment we start learning the centers of the triangle, where these all the formulas will come, and we'll prove it through the logic how we can arrive small r into S or ABC upon 4R for the matter RA into S minus A, S minus B and S minus C kind of thing. So a small r is called in circle radius. In circle radius. So when I draw an in circle inside the triangle, and if I have a radius of it, I can use this small r into S to find out the area of a triangle. Okay, what is capital R? Capital is called circumcircle radius. Circumcircle radius. So when you draw a circumcircle, it means when I circumscribe the triangle, I have a bigger circle, inside it the triangle fits in. This is obviously the center will not be same, it will be something different. This is called capital R. If I have that value, I can find out the area of a triangle is ABC upon 4R. What is RA? What is SA? This is called X circle radius. X circle radius means if I just extend this and try to draw a circle which touches two of the extended side, it may be a bit one step up, and you need to listen this word again and again. We say RA, comma, RB, comma, RC are X circle radius. The question will not be asked directly by naming X circle radius, but they will make a diagram like this. For example, this is the extended side of it, and they will make a circle of this kind. How many such circle I can draw? I can extend this to the bottom and I make a circle here also. Same way I can draw on this side of it. So basically, one triangle can create 3x circle. So we have a 3x circle radius. So this is called RB because it is made on B. This will be called RA. So based on these values, I can find out the area of a triangle. So small RA into S minus A, small RB into S minus B. Very easy to remember. If it is A, then it is S minus A. If it is B, then it is S minus B. If it is C, it is S minus C. And what is unique in this? What is S1, A1, B1, C1? So A1, B1 and C1 are the medians. These are the medians of the triangle. When you draw the medians, and with the help of that median, if I can draw a triangle, if I try to find out the area of that triangle, if I multiply 3 by 4 in 8, I can get the area of a triangle. Basically, this is used in the other way around. They say there is a triangle and we have a 3 median to it. If I draw a triangle with help of that medium, what is the area of that triangle? I can easily say it is 3 by 4 of original triangle's area. And other way around, if a triangle is made with the help of median, what will be the area of a triangle of an original one? I'll say 4 by 3 of area made by help of the medians. So basically what I try to connect today, basically we talked about it, area as a concept. So I don't see any basic rule which is not following all the places. Answer is yes, they follow a one rule, either half base into height, and then we say multiple of 2 side and sine of angle between it divide by 2. And then I try to extend it, how many kind of area formula exist, and based on that we talked about it, how many areas formulas are there. You just write it down for today. I think the coming lectures you will have an explanation for each and everything. Then I also requested we need to learn something, a basics of a trigonometry, which is as basics of this page only, understanding what it mean by sine theta, what it mean by cos theta and other tan theta, and then its values. I think this much knowledge of trigonometry, because sine theta is simple, it can be calculated in a right angle triangle by doing perpendicular divided by hypotenuse. Cos theta is base divided by hypotenuse, and tan theta is nothing but perpendicular divided by the base. So these all the values, if you know, I think you'll be able to do fairly well when it comes to a area in terms of a triangle. And when we see the questions coming into the various examination, 50% questions come from the triangle, and out of 50% triangle question, 50% of that is going to be a pure area related questions. So it is a very, very important concept. Do revise, and you can watch it again and again so that you can make through. And then in next of the videos will come up with the explanation of each and every formula, how they arrived. And since then, keep learning. See you again. Thank you.